Hello all, welcome back to my channel Roshni's EdUnits. You can check out my channel for more education related videos which are related for different streams. Yes, today I'm just going to give you a small topic that is clock domain crossing. See that nothing but CDC techniques. This is very important topic if the people want to go for a VLSI domain. That means if the people want to choose a VLSI domain career, this is a very important topic which is very related to the VLSI domain. So first CDC is nothing but clock domain crossing. So what all the topics I'm going to discuss here is introduction and what are the inputs we are going to give for the CDC, issues related to CDC, metastability, synchronizers, type of synchronizers, rules of CDC, errors in CDC, what is an MTBF and questions related to CDC. Yes, again this CDC I have divided into two parts, that is part 1 and part 2. Part 1 will be till metastability and part 2 will be the remaining topics. So the first topic is I'm saying CDC in the sense clock domain crossing. So I'm mainly stressing clock. So first let us discuss what is a clock. What is a clock? Clock is nothing but it is a digital signal. Clock is nothing but it is a digital signal and it is a square wave. We are having a different waves, no, sine wave, cos wave, everything like that. Clock is nothing but it is a basic digital signal and it is a square wave. Next, the clock, if you see the diagram of the, if you see the picture, the clock is having two levels. The minimum level is 0 and the maximum level is 1. So clock will have always two levels, that is high and low. High in the sense VH is high and its value is represented as 1 as well, we know, and VL is low and that value is represented as no 0. So what is a clock? Clock is nothing but it's a basic digital signal. It is in a square wave. Next, the each and every clock they are having two levels. Those are high as well as low. Here I have indicated high as VH, low indicated as VL, and high value will be denoted as 1 and low value will be denoted by 0. So here we are having for clocks we are having different types. So what are the two types of clocks we are having? We are having synchronous clocks and asynchronous clocks. So first let us discuss about synchronous clock. So what is the meaning of synchronous clock? Synchronous clock is nothing but if we consider two clocks, if the two clocks have a same phase and if they have a different phase also, no problem, we can say those clocks are synchronous. That means each every time if we consider any two clocks, the phase should be same. If it is having a different phase or whatever it is, nothing, no problem, but they should have a same phase. So if they are having a same phase, we can say that though both the clocks were synchronous. Mainly the synchronous clocks were not at all dependent on frequency. Mainly we will decide by seeing the clock whether it is synchronous or not synchronous by seeing its phase. If the phases are same, we can say that the clocks are in synchronous. See here we can see in the picture, the first picture and second picture, here we are having the two clocks and the two clocks are having the same phase. So hence we can say these clocks are said to be as a synchronous. What are a synchronous clock? Synchronous clocks are nothing but if the two clocks are having same phase but different frequency, no problem. Those types of clocks are said to be as synchronous clocks. And how can we decide? By seeing, how can we say that whether they are synchronous or asynchronous? We can say that if by seeing if the synchronous clocks are having same phase. So if they have a same phase, we can say those clocks are said to be a synchronous. Next, asynchronous. Opposite to synchronous. Opposite to synchronous, they should have a different phase as well as different frequency. So those types of clocks are said to be as an asynchronous clocks. So due to this asynchronous, for synchronous clocks, we will be not having a much problem or much issue. But due to this asynchronous clocks, we are having a chance of getting glitches. So to avoid those glitches, first what we will do, we will synchronize these asynchronous clocks before going to a process. So the is nothing but prevention is better than cure. That means, first, if we send the asynchronous clock, we will have a chance of getting glitches. So to avoid the chances of getting glitches, what we do, so before going into the process itself, if we synchronize and send the clock, we will be not having the chance of getting glitches. So hence, if we use a asynchronous clock, we will be having a chance of getting glitches and unwanted data will be received. Hence, to avoid that, what we do, we synchronize and we send to the system before going to the process. So those are asynchronous clocks. So what are asynchronous clocks? Asynchronous clocks are nothing but if two clocks are in different phase, if they are having a different phase or if they are having a different frequency, and those types of clocks are said to be asynchronous clocks. So I told you first the topic is related to CDC, that is clock domain crossing. So first let us now I'm saying CDC, CDC, CDC. So what is a CDC? Is nothing but a transferring of clock from one clock domain to the another clock domain, or a transferring of a signal, or the transferring of a data from one clock domain to the another clock domain. That means from A to B or B to A, from source to destination. That means the transferring of data from one clock domain to the another clock domain, and that technique is said to be as a CDC. So here you can see in a picture I have taken two flops, flop A as flop B, and they are having two different clocks, C1 and C2. So when a signal A is launched by the C1, see, when the signal A should be launched by the C1, you can observe my arrow mark. So the C2 should capture the signal, but based on the depending on the relation between the two clocks, if there is synchronous, okay, fine, they should work with same clock. But here we are having two different clock, that means asynchronous. So based on the relationship, the transferring of the data or receiving from the source to clock domain varies, and that leads to some different condition. So what is an CDC? CDC is nothing but the transferring of data from one clock domain to the another clock domain, that is from source domain to the destination domain, is said to be as a CDC. So, what are the inputs here? When we go for an industrial process, we will be using a tool called spyglass. So, for the to work the tool, if the tool wants to work, so what we should do? We should give some input, right? So, what all the inputs we are giving? Dot .v files, dot .library files, dot .waiver files, and dot .sgdc files. And what are the outputs we are getting? Dot .log files and dot .report files. RPT files are nothing but report files. So, what is a tool we are using for CDC? Spyglass. And what are the inputs? .v file, .library file, .waiver file, .sgdc file. And what are the outputs we are receiving here? After every process, .log file and .report files. These log and report files we should check and we should analyze when you go for an industrial sector. So I said that there is an issue. So what are the issues we will get? Metastability, there is a chance of getting metastability, data loss, and data incoherency. So first let me explain you what is metastability. Metastability is nothing but in each and every flop, when we pass a data, when we send a data from one flop to another flop, if the flop doesn't meet a setup, if the flop doesn't meeting a timing, if the flop doesn't meet timing, in that case we will be having a chance of getting metastability. That means when we send a data from one flop to the another flop, so the data should go and the data should reach the timing requirements. But if in any case, if the data doesn't requires it timing one, if it doesn't meet its timing, that leads to setup and hold violation, and that leads to a issue called metastability. See here you can see every flop that is used in has setup and hold time, right? So even we send the data, so those flops should reach the setup and hold time. If it not reaches, that leads to a metastability. So simply you can say that when we send a data, if anyone asks you what is metastability, you can say that when we send a data from one flop to another flop, the flop should the data or the flop should meet the timing requirements. If it doesn't meet the timing requirement, it lead to setup or either setup or hold violation, and that leads to a condition called metastability. So here you can see clock D and Q. See here, clock we are having. Setup window means before the inactive clock edge, hold window after an active clock edge. So this is a D. So what we are getting Q, either we should get 1 or 0, but we are getting some another metastable case. That means it is not completely to 0 and completely not to 1. So this condition is known as, Q condition is known as metastability. So I told you in the previous slide, setup and hold time. So first let me explain you what is setup and hold time. The minimum amount of time required for the signal to be stable before an active clock edge. Setup time is nothing but, if you see in the previous slide, before an active clock edge, if the minimum amount of time required for the data, if the data gets stable before an active clock edge, and that condition is said to be as a setup. So easy definition is minimum amount of time required for the signal to be stable before an active clock edge. Here active clock edge is very very important. So next, what is hold time? The hold time is nothing but the minimum amount of time required for the signal to be stable after an active clock edge. You can see in a previous slide, after an active clock edge, if the data is stable for a few seconds, and that is said to be a hold time. That is said to be a hold time. So these are the two important definitions, very very important. When you go for an VLSI stream or domain interview, you'll be maximum you'll be having the question, explain regarding setup and hold time. You can just explain the definition. So this is the part 1. I hope you have understood this video. If you have understood, kindly please do like, share and subscribe my channel for more education related videos.